Well, thank you for the direction, Hinky, and thank you for everyone coming here and those who are online. Like Hinky said, I spent a lot of time in quality, and I was just not in testing, I was in a lot of other things like root cause analysis. How do you improve a process? How do you improve your productivity? And after having done that for 20 some years, I decided to go play around with security. And the topics I normally touch are a little bit deeper or a little bit more different than mostly people talk about. We talk about penetration testing, we talk about different types of testing which applies to validate security. And I normally go into an area where I want to understand how we can really improve security while you're building your product. Most of the focus that has been in security so far is, so I got my product, how secure it is. And there is not much focus on how do I secure it to get-go, from get-go. So what you hear from me today is, how do you really understand the attack surface of an application, and how do you want to manage it? What is important for you? What targets are important for you? And how do you really manage that? Agenda here is, I'll try to define what attack surface means. And it's fairly complicated, but we'll stick with some specific domain. How do you measure it? You can run all the tests you want. If you don't have an index, how big is your attack surface? It's hard to know where you are when it comes to vulnerability. And then, how do you really integrate attack surface into your software lifecycle? When I say attack surface, how do you continuously look at the objects you have, targets you have, and make sure their attack surface is optimized, or at least you have not increased attack surface from iteration to iteration? Then we conclude the talk after that. Now, what I'm presenting here is my thinking, my thoughts, and the theory I will apply, and your mileage may vary. There are some things here which you need to be mindful of, and I'll talk about that. Now, Yinky has talked to you about who I am. Here's an introduction about me. I'm a vegetarian. I don't like to eat anything which walks, but something that floats is okay with me. I'm a tea drinker. That's my favorite time. Early morning. I like my tea, nice and hot, with milk and sugar. And I call myself quality champion. I have had that role at different companies, HB being one, Nike being another one. And I just pushed for improving quality time after time. Finally, I'm a freelance researcher. I find things, I talk about those things to people like you, and hopefully you can get some mileage from these things. Now, if you are here thinking about security, you're one of these people. You are either a coder, you write code, you design that code, or you could be a security chief, somebody who is watching the system for, or you could be a hacker. Think about different things. Okay? So this may be one of your roles, maybe not, maybe you're just a quality person and you want to know more about security. So security is not a new concept. The kings have used that forever to secure their castles. You see castles built with a moat around them, a long bridge, and a huge door. And then there are walls which have cutouts to stop the enemy from breaching your castle. So it's not a new concept. Here are some things we need to know. which is that you have some control, you fortify a castle with some controls, and you also make sure that you can stop the enemy with your own efforts as well. So we don't take through all that. So here is what your system is doing like. You have open entries everywhere. You can note these open entry could be like legacy entries, like used to dealing with Windows. They could be developing platforms which you are working with. They could have open entries. You can have back doors. It may have your garage door open. Have things, you may have your back door open. So there are things that exist where people can breach a system from. And then don't forget, the hacker today is very smart. You can buy toolkits at a very, very cheap price. These people, all they do is learn about how to hack all the time by experimenting. By trying to hack, they learn how to hack. So they're always on it. They want to be ahead of you, and we are just trying to follow them. They don't know, we don't know what ways they can come up with to hack your system. Okay. Like I said, tools are very cheap. You can find kits to hack things like you haven't had there before. I'm telling you my experience. I was teaching a class up at OIT, and it was my first class in security. And we had Kali set up and all that, and I showed them SQL injection. As soon as I showed them SQL injection, somebody goes, "Is it that simple?" I said, "Yes, it is that simple." So there are tools everywhere people get thrill out of. There are two types of assets we deal with all the time. Let's look at those two different types of assets. One is compute assets. Compute assets are data. Data you store, you try to protect, and then you have system processes. The processes databases use, or any of your application uses, those are system processes. And you also have legacy systems. I'm talking about, like I mentioned, Windows. You can have other. They also come under your compute assets. And another factor which we should be paying attention to in system hardening, what that basically means is, whenever you are setting up a system and you leave the configurations in default mode, if they're not customized, they're not in your favor. So you always have to look for what defaults should I change to make sure no extra configuration items are open for a hacker. So those are the sites own, they are yours, you use them, and this is what you control all the time. But there are also related assets. Interaction with third-party assets. I don't know if you find a system today in your shop which doesn't deal with third-party software. So there are also those assets where somebody else is building a system for you and you're using it in conjunction with your system. Then we have exposure. These are the things people can use, or the links people can use to come from outside. If you look at some major breaches, they happened because of third-party software. Home Depot had a big breach, and it was because of third-party system. So these are the exposures you have in your system from outside. Deployment. Are you local? Are you all contained? Or are you on the cloud? When you're on the cloud, there are a lot of limitations out there too, because there's other people are going to interact with the system you have, and that's a vulnerability. And then users. You may have, not every user, even in your own company, is good. Users, there may be users in your own company or in your own own clientele, which may be disgruntled and may want to hack your system. So those are other assets which are related to breaches. Okay. All right. So what do we want to really do? We want to guide our development according to the attack surface. And what they basically means is, let's find out what targets are vulnerable. The data, it could be hardening, system hardening, it could be whatever the targets are vulnerable. Let's find out those. Okay? And we'll go beyond that. Out of those targets, which are the important targets. We will try to rank those out, which are important targets in that way. And then we will design code and test our system at that point. Now, we will take that approach iteration after iteration. If we are in agile development, we're going to take that approach every iteration so that we make sure that every iteration, when the new data comes in or the new target comes in, we are taking care of that. And then we want to, that iteration will that be implemented in the bigger SDLC, especially in agile case. Let's define attack surface. It's defined as, I showed you different entries in the house. If you take the sum of all those entries, that is your attack surface definition. All the points of vulnerability, all the entry points is your attack surface. Okay. This is the ways a hacker can get access to your system. And other thing which I will define is an attack vector. That's a vulnerability, and it gets controlled by different things. We will talk about that. And then the next thing is total attack surface. What is your attack surface index once you have considered all the entry points, all the ways, all the attack vectors, in other words. So ASI is your overall attack surface index, which gives you a concrete number. You can say, well, this is my ASI, and next time around, you can compare with your new version of the software. And if the ASI has changed, then you need to think about why has it changed? How can you bring in a control if it has gone back? So 3 things which we will talk about. And then when it comes to attack vector, it has different dimensions here. So remember, attack vector has a target. There's always a goal. A hacker has to breach a particular data point. It could be different data in different environments. And there could also be, the hacker may want to control the process. If you look at the, do not just want to hold on to your portal, or if you look at ransomware, they want to hold on to your data, and they don't want you to see that data, so they are going to control that. That's your, there's a target there. The enablers. Enablers are the things which enable that target. And I'll give you some specific examples. Go to the next one, which is a channel. How do you really go to attack? So if you look at the castle, I showed you, there was a bridge there. Bridge is the channel to attack the castle. If you look at the next point here is control. Control is in the sense, what have we provided? How good is our control to stop the hacker? That's what control means in this context. And then payload. What are we going to use to attack the data or the process we're using? So if we now have some examples we'll talk about, but a simple example would be if you take SQL injection. On a SQL injection, you're trying to get access to the system. That is your target. Okay? The enabler would be a SQL query, and your channel is whatever channel you're using to get to the portal, and then the payload would be the query you have formed to attack the system to get the access. And there is more about this later on. You need to look at this picture to view all that. Yeah. So if you look at this simple picture here, The enabler is the bow itself. Okay. In this particular case, payload is whatever is attached to the arrow, or if your arrow is just arrow, that's your payload, a part of the arrow. The channel again is the medium the arrow goes through, and the target you are hitting. And control in this case would be how well the target is protected. That would be the control if we don't want the target to be hit. Okay, so this is the little bit of an analogy between what I just talked about, attack vector, and how it really relates. So you're all familiar with this environment. You always have a client who's going to browse your portal. And then there is some kind of HTTP call, HTTPS, whatever call you're using. There will be a call that would go to the web server, and then things will be processed at the other end, and you will get backend involved, which may be database, which may be other things. And this is how you will get the data back through the client. So you cannot add much more to it. So if you look at the attack surface, it can be from all sides, and that's what we talked about. I can attack from the client side, and I talked about SQL injection. If you are not using secure transport layer, you can be attacked there, and there is there later on too. But to answer your question, web server cannot, mostly safer than other aspects of it, but then there's the backdoor, there's man in the middle attack. That could be your backend surface. So the next slide really answers your question here. So those are the different ways the attack can be achieved. And we need to really look at areas to protect the portal. Okay. Query is SQL query intended to be the system is an attack vector. A man-in-the-middle attack is an attack vector. They did use different methods to self-service, and they hand the service by bots. That's an attack vector. All those are attack vectors, and they come from different directions. Some may come from the client. Some may come from through the transport layer. Some may come to the back end where somebody is going to third party. Example, and I talked about SQL injection, and these are not just for the show here. SQL injection was OWASP top 10 for a long time. That was the one single attack vector the hackers use all the time, because it gave them access. If they could force through that, they gain access to the system. And earlier systems were written in the way that the admin would be the first user, and they could easily get to the admin. So that's why SQL was the top top attack vector. The next one is man-in-the-middle attack. This is an example for a Facebook breach. Somebody used stolen certificate and AOK from third-party application. So that is where you have the attack through your transport layer. And man-in-the-middle attack comes from the transport layer. The third one is system hardening, a wrong poor configuration. That was for European bank. The system wasn't properly, the server wasn't properly configured, and that led to an attack. The system hardening type vector. And the last one is unlimited login attempt. It was what happens here, the Disney Plus just came in, and when they came on the internet, a bunch of credentials were stolen, and these people, those use those credentials, kept on using those credentials, and different examples of attack vectors. Now, if all of can happen, all these vectors will add up to your attack surface. That can be possibly used. Okay, so now the big question is, what do you protect? Is all data worth protecting? Is my name worth protecting? Probably not. It's probably in everywhere. Is worth protecting. And there are several ways to decide that. And this is what we call risk mitigation or risk estimation, a technique which has been fairly old, has been used pretty widely. And then the STRIDE is an acronym for spoofing. I don't know if I can even remember. Data in transition. It also involves repudiation. When somebody hacks, how can we get back to them, having a record of it? It involves STRIDE. I have it in my notes, so it's in my notes there. So that's one technique. There's a whole bunch of techniques. There is risk tree. You can do a risk tree. And one of these techniques is security card. What security card deals with is there are 4 different areas. I'm only showing you 2 here. Areas are human impact and what is the motivation of a breach of a hacker. Those are 2 things we're looking at here. The other 2 areas are resources the hacker has and the tools the hacker has. So they're all valuable. So for example, if you take a hospital environment, okay, and if there are for example, EKG machines on the network, get to those, somebody need to understand the hardware. So the resources need to be different. And that's why they have taken 4 different categories. And they have, in each categories, they have different aspects of it. Okay. 8 cards. So you take a data point, let's say if I look at a banking operation where people want to hack the bank. Okay? So if you have, it could be different purposes. They want to steal the money. They want to block somebody from getting their money. They want to set their balance to 0. That's all different ways of hacking. So if you look at human impact of that, to me, if my money is gone, I'll have emotional impact. But I will be in financial trouble. Of course, my money is gone. And then this will really impact my relationship with people, even with the bank. For the bank, the relationship will be hurt. And then there is a situation where societal well-being is being hurt. So, and there is no laws for it. You just look at, by doing something, how can they humanly impact somebody? On the other side, what is the motivation of adversary? They might, if they want to take my money, they might take a revenge. Or it could be a monetary benefit to them. So if I look at this, those 2 cards, I have found out there is 4 different aspects on human side and 2 different aspects on the adversary motivation side. So out of those, so I have 6 cards which to me are meaningful, which are going to be effect which are going to have an effect on that particular operation. And I have total of 8 here and 12 here, 20 cards. So out of 20 cards, 6 cards have the promise of infecting me. So by taking that, I can really take a particular operation and define how valuable my targets would be from that. And I'm just going to give you 4 different steps where you want to measure when you are trying to measure the attack surface. So first of all, we want to see what the valuable targets are. Okay? Second, we want to identify the attack vectors. Third, we want to assign a weight to attack vectors. There is no standard attack surface index. You take different portals, some will have X attack surface, some will have Y, some will have Z. There is nothing, there is no standard. If your attack surface is 100, then you're bad. Especially in this particular situation, we are working in making our system more secure. So we just want a relative attack surface index. So you can assign a weight as long as you are consistent with your methodology, as long as you are using the same set of parameters to assign a weight. Okay. It's like when I worked for Nike, we were measuring the stories for agile development, and we would say, okay, this is large t-shirt, this small t-shirt, this is medium t-shirt. It's just a relative reference, and it doesn't matter whether you take a scale of 1 to 5 or 1 to 10 or 1 to 1. As long as you are consistent with the approach you're taking. Okay? So you assign a weight to attack vectors, and you calculate attack surface index. So I'm going to give you a couple examples of the process here and see how they jive with you. Go ahead, John. I already saw. Let's go next slide. Okay. So example I'm going to give you is the tool we use for people. I have worked with that tool fairly extensively. We all have. I never thought I'd be trying to find out. We will come up with a low attack surface index number. How is that? All right. So what this system does is managing membership. They are paid members. They may be paid members. I don't think we have any for members, but they may be paid members. It manages those members. It set of call for papers and manages those. And it also provides a way to rank your proposals and select the top ones you want to include in the conference. And it also has an email messaging system. There is only 2 users on the system, functional wise. You can be an admin or you can be a regular user. And it does not have 2-factor authentication. So you log in, there's no guarantee that you're a hacker or not. There's no 2-factor authentication. It does not have any external links to the portal. It doesn't connect to any other portal. From here, you cannot go anywhere else, so which is safe, I guess. And there is no incoming links either. So these are the characteristics of the portal. So let's look at the next aspect of it. If I look at different attack vectors, why would somebody like to hack the system? Somebody may want free membership. They may want to modify a membership for their own or maybe for someone else. They provide wrong information. They may want to remove, I'm talking about from hacker perspective. Right? They may want to remove a member. Somebody, I don't want this person to be a member. I'm just going to hack the system and get this person out. And I may want to set a membership fee for myself to 0 because that's monetarily helpful to me. I could just shut the whole system down. Denial of service. Just just DOS. So now, with each of these targets, which are number 1, 2, 3, 4, 5, I have looked at those two sets of cards. Looking at the two sets of cards, I have come up with once I have looked at the cards, how many cards are involved here? Everything from 1 to 5. So 6 cards here out of 12 cards. 13 cards, I believe, 13 cards. So this is the number on a scale of 1 to 5. That's the number I'll get. Why am I doing that? I'm just trying to reduce the scale, reduce the large numbers, which I'll get otherwise. So if I did that, no magic here. All I'm doing is how many cards? I had 2 sets of cards, which had total of 8 plus 10, 18 different items, and 6 of them applied for the first one. And so 6 over 18 is what I'm looking at, and I'm just scaling it to 1 to 5. So that's how I get that number. Okay, and I've done that for other targets as well. So this tells me which target is more important. In this particular case, I come up with set a member fee to 0. So if I set the member 0 for maybe X number of people, I have taken the revenge, and I'm good. So then again, you can change to whatever you want to change it to, as long as you are consistent with your approach. Because so these are my target values. So let's go to the next slide where we talk about the controls. I look at my first target. My first target says no two-factor authentication. So my control is 1 to 5, because I don't two-factor authentication, my control is 4. If I have two-factor authentication, my control will be better. So I give a value of 3. I'm using this when I come in, when I log in. I'm using this from using a login form. Can be subject to SQL injection. Okay, so that would be just put a value of 3. I cannot, even if I go into the system, I cannot escalate my privilege. And even if I do, it will not buy me a whole lot. The rows, this is what I should have said here. So now, what I have done here, for this target, there is no, the channel is safe. We are using secure transport layer. The channel is safe. Enabler, in this particular case, the first target, there's no enabler in there. We are trying to steal money. I think that was the first target. And then once we have these controls, and what I could do is come up with a value which is shown here in this right here. All I have done is I squared all the controls and taken a square root. So I'm still trying to figure out. I've seen this example before in papers that have been published, but I think what they try to do is they try to reduce the spread between different factors. At this point, I have, for all the targets, I have looked at the enabler, I looked at the channel aspects, I look at the control aspects, and I come up with every one of those with an index. Case here is the top one. If you look at the second one, the index is 2.62, 3.51. So it gives different pieces of information. One is which target is more valuable than other, which I did that before when I was looking at. That told me it's like a prototype thing. Which targets are more valuable than the others, and then out of those targets, then how is the control? Or what are the vectors? Well, not the control. What are the different values of the components of the vector, so that I can understand attack surface? So if you take that approach, If you add all those numbers, you will get an attack surface index. I think I have talked about most of these things here. You have to properly identify high value target. And I'm not saying use this card method. There are other methods to use. Whatever makes sense to you, whatever you feel more comfortable about, you can use that. I use it because I thought it was a very correct mapping from what the target is to what the impacts are. That's why I use it for. And one person should be involved in this process. Maybe team should be involved. Same approach. Write them down, jot them down. Keep the same approach. I scaled vectors on 1 to 5. You can scale to any other value you like, but it makes sense to keep it low. I say it again, consistent approach. And like I said, ASI is not an absolute value. This paper here, Herman Keller and True paper were written in 2012. And I'm surprised to put to practice. What they did in their paper, they took all assets, computed assets and related assets. And then they came up with an approach, similar approach. Things that is, if you're looking at the entire picture of your application, that would be the way to go. But here, because we're developing a system, we're going from what I have given here will suffice. So if we did that, and anyway, so this approach, similar approach was used by really predict the attack surface index of your application.
How do you know that others aren't using that?
I just don't see anything in when we talk about ASI, talk about the surface, all they talk about is non-penetration testing. Here's a tool done your TAST, dynamic application static testing.
So
they're not even going there. We're looking at different aspects of their objects. They're not just two. I sat through a webinar last week. None of this came out. They just say run penetration testing, look at this inject, look at different.
What you're saying, components of the tool. So they're just running tools.
Right.
This tool guy.
Right, and the tools don't touch at this level either. They look for SQL injection.
Right, but they don't understand
Under aspects of it. So that is the main difference. If you look at, or even if you look at these two, like I said, they're both scalable. The one by Herman is not really, you can use it for during your development, but it's too cumbersome for development because Lucas also looks at the norm. You can use either one of those or both of those. You have to see what it is. But you'll get new targets all the time. You'll get new objects all the time, and you can every iteration you can look at it. How you can measure it.
I'm sorry. So it seems like one on the right would be better for an agile environment.
Right. I think the next slide here, I believe. Can we go to the next one? See anything here? Dropped everything from them. There's no other one, right? This is the only one I give you. So this is no, this is where this quadrant right here is where you are going to look at the targets and try to understand the attack surface. And then you run it through your regular process, and that would give you you all build systems, you all know how systems work and all that, but in my mind, I have to have good control. If you want to build a secure system, you have to have good access control, both on objects and processes. Get your data as much as you can. Like I said before, a lot of systems have been breached because of improper. Have a good security validation approach. I will also say it's a team effort. It's not a one-person thing. I don't know how many of you have a security engineer. Have you ever been breached? Have you, well, there are some online too. Have you ever been breached? Hmm?
On a monthly basis,
On monthly basis.
and they would say they're not, so.
The next question would be what is your confidence level in the security of your system? High, low, and if it is high, why is it high? What makes you think is this just because it hasn't been breached, it has high level of security? No, that's not true.
Yes, some places that I've been to say they have never been breached, but then you ask them, how do you detect it? Or detect, they don't have anything set up to
Right.
detect breaches, so
Mhm, mhm.
therefore they've never had it. Want to know? They don't want to know. You don't know, there's no problem.
So I think we have some last slide there. So we are kept in this particular scenario where we're dealing with iteration after iteration. After release, we are looking at comparative index. There's no absolute. Trying to look for high risk targets and try to secure those high risk targets. With the methodology, whatever methodology you use, as I said, there is at least 6 different ways to look at risk mitigation. Even Stride has 5 different variations. So whichever we want to use, just be consistent. And then, as I said before, it's not just one person's job. It's the entire team is to look into it. Again, I'm saying there's no absolute measurement for it. I think this is the end.
Have you looked at all about hacking the human? Pretty breach started out with somebody's laptop or something.
Doesn't look at those. So this is mostly computer assets, not generative assets. Yeah, these are mostly technical. Yeah. So if you no, it doesn't look at those particular scenarios. And it could happen. It could. There was a breach that happened. I think the European bank I mentioned here. It was breached because of some ex-worker just went on their site, found some patient and she could
AWS,
consult.
AWS.
It was AWS, yeah.
The person left the company and they
Right.
just saw and still had access. and
AWS, like I said, this only looks at, we are going by the fact that let's find out the most valuable targets while you're building the system.
How would the use of commercial cloud or gov cloud be factored into the house?
So that would be an external factor. There is, so that's there will be different analogy to how we use, how we extend it to cloud management. So you gotta look at the users who's accessing it. How is it being deployed? Are they really looking at the segmentation of the memory, whatever area they give you, whatever memory, whatever hardware they're giving you? How rigidly they are watching that. So those are the kind of factors they will give a look at. What is the configuration again?
One way that GovCloud achieves higher level security is that they turn services.
Hmm.
Sure, that you don't have a lot of funding.
Always a trade-off between scope of services and security. Yeah.
So the other thing, if you look at health industry, they don't get hit by any, they get hit by ransomware. Get hit by ransomware. So all hacker wants to do is just encrypt the database and give me the money.
Thing is that as you're developing and changing software, you're looking at a very small point in time. You could be a client that's good
Yeah,
today, 5 tomorrow, so that's.
yeah. When next it takes, yeah.
Back.
Yes, yeah. So when you are at 5, then you want to think about what do I do? How do I control it?
Tools that assess all this.
Right,
quickly.
right. Yeah,
It's
yeah.
gonna tell you.
Yeah, I wanted to. I don't know how to write it. I can only write, but I mean, look, the tool thing I would think for like 5 years. And you can cover something up just by what is out there in open source.
So,
Yeah.
The PNSQC membership system is analyzed.
Yeah.
How bad? That should be shown. I go here.
So we are not that bad. Okay. So there is no financial impact, hardly any, because nobody's getting money at this point. There's no financial. How would somebody who has not been accepted for the conference improve their ranking so that they can be accepted? Because we not only go by the system, we also look at training. We are not, given the way we are using the system at this point, we're not bad. There is only 2 user roles, so there is no big authentication problem either. And even if I get in there, what would I change?
Well, they consider it to be an effective reputation.
That is important. So I would say, if these member league people, I think they should build in some 2-factor authentication, and that would make it very, very robust.
Especially for the admin.
Right.
That not just user
Right.
signing up and
Yeah, that would make it robust.
the portion that.
Okay, so Mons, you going to talk about the call for paper? So you probably know. Yeah. I can give you this and you can go ahead.
Oh, that's all I knew. Oh, all right, who am I talking to about it? So it's the 41st annual Software Quality Conference, Pacific Northwest Software Quality Conference. And is it showing the so recording? Share my screen there. There it is. Yeah, from the Zoom meeting, go ahead and click on share. So here's a quick preview. '41st annual Pacific Northwest Software Quality Conference. That's going to be in October. It's usually what has been called a Columbus Day, or we could call it Indigenous Peoples Day. And the theme is Amp It Up, Transforming Quality. We have a little tube amp there. You can see the tubes very well on that one. But the idea is, how can your voice in your organization be amped up in order to transform quality throughout the organization? And that may be as small as being better communicator for describing bugs, or it could be leading change and initiatives for improving just the total process of developing software. So there's a wide range there. We're looking for people who have ideas about these concepts and to submit an PNSQC in October at the conference. And it takes, just write a couple sentences, maybe a paragraph about your idea for the paper, and you can submit it at pnsqc.org. The call for proposals is open until April 16th, Sunday, April 16th. Were there any other things that I missed? Thinking of basically ways to improve software. So it could include management, it could include testing, it could include development processes, it could be new technology like AI, it could be security tools, a wide range of topics.
Maybe the process. So we submit an abstract.
Process. Yeah, go ahead and type up your abstract and submit it. You can actually, if you have a couple different ideas and you want to frame them differently, submit them to the pnsqc.org website. And then we have a review committee that will go through and kind of assess the papers in terms of what fits in the program and what will be diverse for conference attendees. And then you'll be notified around the 1st of May whether that paper is accepted. And then we'll assign some paper reviewers to your paper and help you develop the idea into a full 10 or 12 page paper, which okay.
What about it's published in the proceedings?
And it gets published in the proceedings. You should be up here too with that.
How about the conference resources?
You can still do the author resources, sure.
And a little bit of the timeline.
Yeah, they're in the you can see on the screen the call for papers is open until
This is April 15th. I think it's actually April 16th. And then we'll notify the authors, and then you can see the dates for kind of guiding through the paper process. And this page also has instructions for authors, templates about using how to develop paper. How the proposals are selected.
This may be a good plug for volunteers to participate in the review process.
Yeah, sure. We're looking for reviewers. People are interested in the.
Our guidance for the reviewers and for the authors that's provided on here for those that are interested in becoming authors or reviewers.
As Yankee points out, there's guidance there and for authors and reviewers. And I think that wraps up the program. What time is it?
7:30.